So, let's talk about one of the most fundamental numbers in all of science. It's a number so mind-bogglingly large, it's almost impossible to picture, but it underpins pretty much everything we know about chemistry and, well, the entire material world.
And here it is. This is the Avogadro constant. It's the number of particles, atoms, molecules, whatever, in one single mole of a substance. Just think of a mole like a chemist's version of a dozen, but instead of 12, it's this. This is the number that lets us count the very building blocks of our universe.
Okay, so let's really dive into this, because the story behind this number, it is absolutely not what you might think. It's this incredible tale of a brilliant idea, a forgotten hero, and a century-long quest for precision that literally changed how we define the world around us.
To get started, we've got to go all the way back to the early 19th century. We need to meet the man whose name is, on the label. Amedeo Avogadro, an Italian scientist who had a truly revolutionary insight.
So back in 1811, he publishes this idea. Now, you have to remember, this is a time when people were still arguing about whether atoms even existed. And he comes along and says, look, if you have two balloons, same size, same temperature, same pressure, they have the exact same number of particles inside. Doesn't matter if one is filled with hydrogen and the other with oxygen, same number. It was a huge leap.
Right, and here's the crucial part. Avogadro gave us the what, the big idea, but he didn't give us the how many. He laid all this amazing theoretical groundwork, but the tools to actually figure out that number, they just didn't exist yet. So he never ever knew the value of the constant that would one day have his name.
So now the story jumps forward more than 50 years to the first person who actually managed to put a number to Avogadro's big idea. And spoiler alert, his name is not Avogadro. This is where we really have to separate the two key pieces. The theory, the concept, that belongs to Avogadro. But the first ever calculation, that belongs to an Austrian physicist and chemist named Josef Loschmidt. Truly, the unsung hero of this entire story.
And Loschmidt's life was, anything but glamorous. He came from a poor family, and after a business he started went bankrupt, he ended up as a high school teacher in Vienna. He was doing this groundbreaking research not in some fancy university, but in his spare time, in a tiny school lab. His method was just so clever. By studying how gas molecules move around and how far they travel before bumping into each other, he basically worked backwards to make the first ever estimate for the actual size of a molecule. From there, he could calculate the number of those molecules in a set volume of gas. His estimate wasn't perfect, of course, but it was in the right ballpark. For its time, this was just a monumental achievement.
But Loschmidt's work didn't end the story. Oh no, it kicked off a race. For the next 100 years, scientists from all these different fields, using wildly different methods, all tried to nail down this one massive number with more and more and more accuracy.
I mean, just look at how this race unfolded. You start with Loschmidt and his gas theory. Then Max Planck comes along and calculates it from his work on quantum theory. Then Robert Millikan gets an even better value by measuring the charge of a single electron. And then, by the 1970s, you have scientists creating these perfectly round spheres of pure silicon and literally using X-rays to count the atoms inside. It's incredible.
It's just amazing to see the whole toolkit of physics and chemistry that was thrown at this one single problem. Each one of these methods was like a different window into the atomic world, and every time we looked through a new window, the number we saw got just a little bit clearer.
Now, all of this effort, this century-long obsession with measuring a number more and more precisely, it actually led to this really fascinating and profound philosophical shift in how we even think about the number itself.
In 2019, scientists just flipped the script entirely. See, for decades, the mole was defined by the mass of carbon-12. That meant the Avogadro constant was something we always had to measure, and it always had a little bit of uncertainty. But after 2019, we just fixed it. The constant is now defined as an exact value. We literally stopped measuring it.
It's no longer some value we have to go out and discover in nature. It's now a fundamental yardstick that we've defined to measure nature with. It's joined the ranks of other huge constants, like the speed of light, which are also defined as exact, unchanging values.
So, why does any of this matter? Why would we spend over 150 years chasing a single number only to turn around and just define it? What does this whole journey mean for us?
Well, It matters because this number is the one essential bridge that connects two completely different worlds. It links the invisible, microscopic world of individual atoms and molecules to the macroscopic world of grams and liters, the world we can actually see and touch and measure in a lab.
And it's not just some random number floating out there, it's a keystone. It locks together so many other fundamental constants in physics and chemistry. It's the thing that relates properties of single particles, like the charge on one electron, to properties of a whole mole of particles, like the Faraday constant. It's the glue.
Which, brings us right back to the beginning. It feels right to end with these words from Ludwig Boltzmann, talking about his friend and colleague, the guy who first gave us a peek at this monumental number. He knew that Loschmidt, with his brilliant work and his humility, had laid a cornerstone for all of modern science. And it really makes you wonder, doesn't it? How many other scientific constants and ideas that we just take for granted have a hidden human story of curiosity and struggle and discovery, just waiting for someone to tell it?